All right. All right. Hello, everyone. My name is Mark Gillette, and I'm a NASA JPL Solar System Ambassador. And I'd like to welcome all of you to my presentation today entitled What's Up at NASA. And I would especially like to welcome those at the Prattsville Public Library in Alabama. Welcome. So during my presentation today, at any time, if anyone has any questions, feel free to type them in the chat box, and periodically I will pause to take a look at if there are any questions in the chat box, and I will do the very best job that I can of answering those questions as they come up. So please feel free to do that. If you have any questions, also type them in the chat box. So I'm so glad that you're here. I want to take just a moment to tell you a little bit about who I am. I am a native of Central Florida. I actually live about 15 to 20 minutes away from the Walt Disney World Resort, just south of Orlando, Florida. I am a full-time sociology professor at Valencia College. I've been teaching there for about 25 years. In addition to being a full-time college professor, I also have a number of hobbies, including travel. I'm an avid traveler. I've been very fortunate to travel to all 50 U.S. states. I've traveled to all 7 continents, yes, even Antarctica, and I've been to around 60 countries all over the world. I really enjoy traveling. I learn a lot about other people, other cultures, and I ultimately learn a lot about myself, and I think that's a pretty cool thing. In addition to travel, I also enjoy astronomy, anything to do with astronomy, hence the reason that I am presenting about NASA today. I am an amateur astronomer. I have a telescope, and I set it up outside my home periodically when the weather permits, and I will take some pictures of nebula and stars and galaxies. In just a couple slides, I will be showing you one of my most recent pictures of 2 galaxies. So you might be asking, well, what is a sociology professor doing talking about astronomy? Because they are 2 very, very different fields. And it's very simple. I'm very enthusiastic about astronomy. And so NASA has this program. It's called the Solar System Ambassador Program, and it's a joint venture between NASA and JPL in Pasadena, California, where volunteers like myself will become accepted into the program through an application process. And then we do presentations to the community and talk about anything related to NASA and space. So I've been a part of the NASA Solar System Ambassador Program now for about 1.5 years. I'm thoroughly enjoying it. Generally, what I will do is go out in my local community to public library, science center, even to the jails to do live presentations on site. But of course, with the COVID-19 situation that we have, all of these facilities are closed or not allowing visitors to come in. And so I've decided to move my presentations online, much what I'm doing here. So I've done a few of them now. I'm feeling more and more comfortable doing these. At the beginning, it was very odd because I'm sitting in my home staring at my computer screen with no interaction. And generally, as a sociology professor or presenting in a library, I see faces, and faces will tell me what's going on, body language. But here I'm just simply looking at a screen, so it is very odd, but I think I'm getting used to it. So I do like to have this as participatory as possible, which again means feel free to type any questions that you have into the chat, and I will address those as we go along. I want to tell you quickly about 3 upcoming events that I have, YouTube live events. These will be very specialized and very different than the ones that I've offered in the past. The YouTube live events that I've offered in the past have basically been about NASA specifically, the past, the present, and the future. But these are going off into very specific topics that I think that you might find interesting. And if so, please make sure to mark your calendar and join me back here at my YouTube channel to learn about these topics. So on Tuesday, July the 28th from 7:30 to 8:30 p.m. Eastern Time, I will be doing a talk about is there life beyond Earth? So I will be talking about different organizations that are looking for life beyond Earth, like the SETI Institute. I will be talking about Mars, Enceladus, Europa, Titan, some of the moons of Saturn and Jupiter. And so I think that you will find it quite interesting. On Monday, August the 24th from 7:30 to 8:30 p.m. Eastern Time, and these are all Eastern Time, so for those in Alabama, you will want to adjust them by 1 hour. I will be presenting on what I'm calling Twinkle Twinkle Little Star, and no, it's not necessarily geared to very young children. I'm just kind of playing off of a title here. And this presentation will be all about stars, big stars, little stars, the lifespan of stars. I will be talking about our star, the sun. And so if you're interested in stars, please join me on Monday, August the 24th. And Wednesday, September 30th, from 7:30 to 8:30 p.m. Eastern Time, I will be talking about the planets. All right, so please mark your calendar for those. And probably in August or early September, I will come up with my presentations for October, November, and December. So with that said, please make sure that you subscribe to my YouTube channel, turn on notifications. That way you know when I post a new promo for the upcoming YouTube Live NASA presentations. All right. I don't see anything in the chat box, so let me go over our brief agenda. I want to very quickly talk about the past of NASA, talking about the Apollo program and the Space Shuttle program. And then we will transition and talk a little bit about, well, what's NASA doing right now? We'll talk about the International Space Station. We will talk about satellites, landers, and rovers. And we will talk about NASA's Commercial Crew Program. And then we will transition and spend a little time talking about the future, what's planned. We will talk about the James Webb Space Telescope, the SLS, or the Space Launch System, and Orion Space Capsule, which is part of the Artemis program. We will talk about the moon human landing systems that are planned for our return to the moon in 2024. I will show you some opportunities that you can experience NASA for yourself with some really cool websites and software. And then we will hopefully have some time for Q&A at the very end of the presentation. All right, so hopefully you find something up there interesting. I promised earlier I would show you my most recent image that I've taken. And on the right-hand side of your screen, you will see M81, or Bode's Galaxy, on the left-hand side of the image, and M82, the Cigar Galaxy, on the right-hand side. And both of these galaxies are approximately 12 million light years from Earth. And please keep in mind that I did not say 12 million miles from Earth, okay? Because the universe is so incredibly large, we can't measure distances with miles because it just doesn't do the job well. So we talk about light, how fast light travels. Light travels at about 186,000 miles in 1 second. And so if you do the math, these galaxies that you're looking at are really, really, really far away. All right, so let's talk a little bit about the past of NASA then. So NASA was formed back in 1958. The first major program was the Apollo program. However, there were 2 other programs that led up to the Apollo program. Project Mercury, followed by Project Gemini. Project Mercury was really focused on simply getting Americans into space, because back during the early 1960s, there was a space race between the former Soviet Union and the US. And we weren't doing very well, so there was a rush to get an American into space. And the first American astronaut was Alan Shepard. All right, and then that led to the Gemini project. And that project was really focused on testing out the systems, like the software and the hardware needed to make the Apollo program successful. All right, and then we transition over to the Apollo program, which officially started in 1961 and ended in 1972. The first Apollo, Apollo 1, unfortunately ended in tragedy, where we lost 3 astronauts, Roger Chaffee, Ed White, and Gus Grissom. They were simply doing a test on the launch pad at the Kennedy Space Center in Central Florida, and things did not go well. There was a fire, and the astronauts were unable to escape, and so they lost their life. Apollo 8, in December of 1968, was the first time that humans orbited the moon. And of course, perhaps the most famous of all the Apollo program missions was Apollo 11, when humans first landed on the moon, and that occurred on July 20th, 1969. And so in 4 days from now, we will celebrate the 51st anniversary of humans landing on the moon. And we just about a year ago celebrated the 50th anniversary. So let me show you a quick little video about the 50th anniversary of the Apollo program.
Choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
T-minus 60 seconds and counting. We are go for Apollo 7 at this time.
And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
We have ignition sequence start. Engines on. 5, 4, 3, 2.
Listen, Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind. We leave as we came, and God willing, as we shall return, with peace and hope for all mankind. We're on our way, Houston.
From 1969 to 1972, we had, a total of 6 moon landings. 12 humans walked on the surface of the moon. We have elevated the human condition. We have improved human lives. We have raised the standard of living for every person on Earth because of space exploration.
Okay, so I hope that you enjoyed that short little video. There were actually 6 moon landings, starting with Apollo 11, followed by Apollo 12, 14, 15, 16, and 17. On each mission, there were 2 men that walked on the moon and stayed for different duration amounts. Apollo 13, as you know I skipped, was in April of 1970, and they had a major problem. They had an explosion while steering the oxygen tanks. And if you've not seen the movie, I highly recommend the movie entitled Apollo 13. It came out quite a long time ago in 1995. Tom Hanks is the primary actor in that movie, but it's a very interesting movie, and I think that you will find it to be entertaining as well. There were 3 Apollo program missions that were canceled due to lack of interest among the American citizens and cut in funding. Apollo 18, 19, and 20. On the left-hand side of your screen, you will see the Saturn V rocket, named after the 5 main engines of the Saturn V rocket. And on the very top here, this is where the command module went, and that's where the astronauts were in. And then when they returned back to Earth, this is the command module, and it would splash down into the Pacific Ocean. This is a quick little overview of where we landed on the moon. On the left-hand side of your screen, you can see the Apollo mission. On the right-hand side of your screen, you can see the patch that is related to that specific mission. I'll give you a moment to take a look at that. One of the things that I will encourage you to consider is, where are the landings taking place? And you will notice that for the majority of them, really they are very near the equator of the moon. And that's important because when we go back to the moon in 2024, we will not be going to the equator. The destination is actually the South Pole. And the reason that we're going to the South Pole is because there is water there, ice water. And that can be used not only, of course, for sustaining the astronauts that will be there for much longer durations of time than what you see on your screen here for these missions, but also the hydrogen can be separated from the oxygen, and that can be used to propel the rockets. Okay, so there you go. All right, I'm not seeing any questions, anything in the chat box. So the next major program was the Space Shuttle program. The first Space Shuttle launched in 1981. That was Space Shuttle Columbia. And Space Shuttle Atlantis was the last shuttle used and landed at the Kennedy Space Center in 2011. Now, this was very different than the Apollo program in that the Apollo program, the mission was to go back and forth to the moon, whereas the Space Shuttle program was focused on taking astronauts into low Earth orbit. All right, so you can see the shuttle here landing at the Kennedy Space Center, and on the left-hand side it is attached to the external fuel tank, the solid rocket boosters on either side, so it launched like a rocket, but it landed like a plane. Unlike modern aircraft that have engines that will assist in landing, the Space Shuttle did not have any engines that would assist in landing, so in essence it was a glider. So the astronauts that were flying it had to make sure that they knew what they were doing because they only had one opportunity to land. They could not go around, per se. Luckily, with the 135 missions that they had with the entire Space Shuttle program, there were 5 space shuttles. They did not have any problems landing. The 5 orbiters were called Columbia, Challenger, Endeavour, Discovery, and Atlantis. Unfortunately, we lost 2 of the 5. Challenger exploded about 73 seconds after launch in 1986. We lost 7 astronauts. And in 2003, the Space Shuttle Columbia, upon descent and approach for landing, basically fell apart when it was flying above Texas and Louisiana. And unfortunately, we also lost 7 astronauts in that disaster as well. When the Space Shuttle went into space, it again would be in low Earth orbit, about 250 miles above the Earth. It would travel at 17,500 miles per hour. It would only take about 90 minutes to completely go around the Earth. All right, I got a little quick video here to let you see the Space Shuttle launching from the Kennedy Space Center in Florida. And I'm going to move this forward.
1 minute, 30 seconds.
To right about there.
20.
If you've never seen a launch,
is armed. Sound suppression water system activated.
I highly recommend.
T-minus 10, 9, 8, 7, 6, 5, 3, 2, 1, 0, and liftoff of Space Shuttle Atlantis on a mission to build
resupply, and to do research on the International Space Station.
Houston now controlling. Atlantis begins its penultimate journey to shore up the International Space Station. Atlantis now in the proper alignment for its 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Outpost. 30 seconds into the flight.
If you've never seen a rocket launch, I highly recommend, if at all possible, that you try to do so. Of course, the Space Shuttle program ended in 2011, so you're not going to see a Space Shuttle launch, but we do have a lot of launches occurring both at the Kennedy Space Center and Cape Canaveral Air Force, just south of Kennedy Space Center in Central Florida. I will be showing you a website a little bit later, spaceflightnow.com, that will tell you all about upcoming launches, not only here in Florida, but all over the world. And so if you ever get the opportunity to see one, it is truly an experience. I've had the opportunity to see a couple up close, and if you go on my YouTube channel and kind of look at the different videos I have there, you can see a few of them being launched. So I'm going to also fast forward this one so we can kind of see
traveling 1,700 miles per hour.
The final approach.
Traveling at a rate of 370 miles per hour.
Again, this is a glider. They have no
30 seconds
engines
until touchdown.
that will assist them in landing, so they must get it right. If they don't get it right, they're going to crash. And again, things went well. They did get all 135 space shuttles landed.
Main gear. Landing gear now down and locked. Main gear touchdown. Pilot Jim Dutton now deploying the drag chute.
All right, and there you go, space shuttle landing.
No.
Okay. If you happen to go to the Kennedy Space Center Visitor Complex here in Central Florida, you can see the actual Atlanta Space Shuttle on display, the actual shuttle that went into space. If you are out in California, you can go to the California Science Center and see the Endeavour Space Shuttle on display. Again, there's one remaining one, Space Shuttle Discovery, that's located at the National Air and Space Museum near Dulles International Airport in Virginia, right outside of Washington, D.C. All right, so now we're going to transition and talk about what is NASA up to at the present. And I want to start first by looking at this image that you can see on your screen, and this is all of the current and also includes planned missions that NASA is a part of. And as I often say when I show this, when I first saw this, I was amazed because I knew that NASA was doing a lot, but I had no idea that they were involved in this many missions. And so I'm not going to go through all of these, but here NASA has missions that study deep sky objects and galaxies. We have the Earth and the Moon. We have our star, the Sun. We have planets. So there's a lot of stuff going on. If you go to nasa.gov, their main website, you can learn about any and all of these current, past, and planned missions. Let's start with the International Space Station. The International Space Station was constructed predominantly in the late 1990s and then the early 2000s. It is a cooperative among a number of countries all over the world. It orbits the Earth at about 250 miles above the Earth. It travels at 17,500 miles per hour, which means that it only takes roughly about 90 minutes to orbit the Earth, much like what I was talking about with the Space Shuttle. It's roughly the size of an American football field. On the right-hand side of your screen, you can see the current patch for the group of astronauts and cosmonauts that are inhabiting the International Space Station. They are currently on what's called Expedition 63. So for every expedition, they come out with a new patch. An expedition normally will last roughly 6 months. Some astronauts or cosmonauts, as they call them in Russia, could stay longer or shorter based on their mission. Right now, there are currently 3 humans above us at 250 miles on the International Space Station, 1 American and 2 Russians. They're part of the Expedition 63. Actually, there are 3 Americans on board right now because there were 2 astronauts that joined them on March 31st. And I'll talk about that in just a few minutes as part of the commercial crew program. So right now there are 5 people above us at 250 miles. All right. The International Space Station was first inhabited back in November of 2000. So in just a few months, it will make 20 consistent years that humans have lived on the International Space Station. Okay, let me see here. I'm not seeing any questions in the chat box. So I want to tell you about how you can see the International Space Station from where you are. And it's relatively simple. All you need to do is go to this website, spotthestation.nasa.gov. Go to sign up. I'm not going to go through the process, but basically they're going to ask for your location and your email address. And then once you provide that information, what will happen is you will receive an email when the International Space Station is visible from where you are, generally about 12 to 18 hours before the actual sighting. On the right-hand side of your screen, you will see what the email will look like. It will tell you the day and the time that it becomes available to you in the sky, how long you can see it, in this case 6 minutes, and then it will tell you exactly where to look, what direction it will travel, and where it will disappear in the sky. So you need to be familiar with where you are, your north, east, south, and west, and your angles, from ground level up to the top of the sky. If you know the degrees, if you can estimate, it's not very difficult, up to 90 degrees. So if you can do that, you know where you are, you put it together, you know exactly where to look, and what you will see is this right here. You will not see, when you look up, I guarantee you will not see this. Okay, it's too small, it's too far away. What you will see is a little white dot going across the sky very slowly. Well, it seems slow to us, but do keep in mind they're going 17,500 miles an hour. So you'll see that little white dot going across the sky, and that's the International Space Station. So spotthestation.nasa.gov. All right, let's talk about some satellites. Back a long time ago, back in 1977, NASA launched 2 satellites, one called Voyager 1 and one called Voyager 2. The main mission was to explore the outer planets, like Uranus and Neptune. But they've lasted a long, long time, much longer than what they were designed to last. So at this time, both Voyager 1 and Voyager 2 are in the process and are leaving our solar system and are now in what's called interstellar space. I want to give you some quick details about Voyager 1 and Voyager 2. They're 2 separate satellites. Both launched within about, I think it was within about 4 weeks of one another in 1977. Voyager 1 currently has 4 working instruments. Voyager 2 has 5. Both of them started with, I think, 10 instruments each. And you might ask, well, if they both had 10 instruments, and Voyager 1 only has 4 working, and Voyager 2 only has 5 working, why? Well, because they have a limited supply of energy to keep them moving. And so in order to conserve the power, the astronauts, I'm sorry, the technicians that are controlling and communicating with these satellites have decided to turn off some of the instruments to conserve power. Right now, Voyager 1 is approximately 13.8 billion miles from Earth. Voyager 2, 11.4 billion miles from Earth. So they're really far out. Voyager 1 is traveling at about 38,000 miles an hour. Voyager 2, 34,000 miles per hour. You may or may not have ever heard about the golden records. Each Voyager 1 and Voyager 2 has a golden record that's on the side. They were put there in the event that any type of extraterrestrial life that might be out near our solar system, and if they encounter Voyager 1 and Voyager 2, it will give them some basic information about where these satellites were launched from. So if you aren't familiar with the golden records, as they are called, I highly recommend that you look them up on the internet, and you can find some pretty interesting information about that. All right. Let me read here in the chat box. All right. So, on the right-hand side of your screen, you see what I believe perhaps to be the most popular of the things that NASA has launched without astronauts on board, and that's the Hubble Space Telescope. The Hubble Space Telescope was launched back in 1990. It is about 350 miles above the Earth, so about 100 miles higher than the International Space Station. It also travels at about 17,500 miles per hour, and it's the size of a small bus. Many of the pictures that you've probably seen from space that come from NASA probably have come from the Hubble Space Telescope. There were a number of issues with the mirrors upon launch that were corrected with some space shuttle missions that went up and captured the Hubble, brought it in. Astronauts did spacewalks. They fixed those defects in the mirrors. And so it has provided us just a large number of incredible images of our solar system and the galaxy. So we are celebrating 30 years of the Hubble Space Telescope as of just a couple months ago. Here is perhaps the most famous picture from the Hubble Space Telescope. It's called the Hubble Ultra Deep Field Image. And what happened was some scientists that had control of Hubble decided to point the cameras in what they thought was a non-discrete, non-interesting section of the sky. They took a whole bunch of images over many hours. They stacked those images and they put them together. They merged them together. When you take pictures of deep sky objects like galaxies, it's all about collecting light. And so the longer you keep your shutter open, the more light you collect, the more you get to see. And so here's what we found. 10,000 galaxies in that very undiscrete area of the sky. And so this basically shows us that there are billions upon billions upon billions of galaxies in our universe. And everything that you're looking at in this image, with just a few exceptions like this and like this, these are stars. But most everything else that you see here, these are all galaxies. Consider that every galaxy is made up of millions and millions and millions of stars that are gravitationally linked together. All right? And so pretty incredible. Let's talk about landers and rovers. So on the right-hand side of your screen, you see the Mars Curiosity rover. This landed on Mars back in August of 2012. Now, since being on Mars, Curiosity has traveled about 14 miles on the Martian surface. 14 miles may not seem very much to you and me here on planet Earth, but when you think about all of the engineering and everything that it took to put that thing together, to launch it, to land it, and to get it on to the Martian surface, and to get it to even move around, that's pretty incredible. So even though the Mars Curiosity rover was designed only to last for a very limited period of time, it has been working now for over about 8 years, and that's pretty cool. On the left-hand side of your screen, you can see the earliest addition, NASA's addition to Mars, the Mars InSight lander that landed in November of 2018. Now, notice the difference here. The Mars Curiosity rover has wheels and therefore moves around. The Mars InSight lander has no wheels. It's a lander, which means it lands and it stays put. So it's extremely important that they land it where they want to land it, because it's not moving after that. And indeed, they were able to land it where they wanted to land it. And so both of these missions are geared towards not only learning more about Mars, the geology and the atmosphere and temperature and so on and so forth, but also looking for signs of life, current or past life. And that may not be the green little men with the antennas on their head, but it's probably microbial life, very, very small life that has may need a microscope, will need a microscope to actually find it. Right here you see the digger, and the ultimate goal is to use this to dig down 16 feet below the Martian surface. And so because there's so much radiation from the sun that affects Mars, keep in mind that Mars has a very, very thin atmosphere. It is bombarded with radiation from the sun, and so it really does a lot of damage to the surface of Mars. And if there was any past life that would be on the surface of Mars, the radiation and the sun would basically destroy it. So if we're looking for past or current life, we're going to have to dig down, and so that's the goal there. Now, NASA's newest Mars rover, Perseverance, originally called Mars 2020, is set to launch in just a few days. So it was renamed Perseverance back in March from an American student who entered a contest and won. It was originally scheduled to be launched on July the 17th, but they found a few issues with the rocket that's being used. The rocket is an Atlas V United Launch Alliance rocket, and so it's been delayed a few times because of those problems. However, it appears at this time that the problems have all been worked out. They're doing final checks, and so currently the schedule is for July 30th, 2020, between 7:50 and 9:50 a.m. Eastern Time. That's when it's supposed to launch. On the left-hand side, you see an illustration of the Perseverance rover. It looks much like what we were looking at here with the Mars Curiosity rover. It's just simply updated with more instruments, more high-tech, and it has the ability to cache soil samples, which basically means that one of the goals of this mission is to collect some soil, put it in containers, set it aside, and a future NASA mission will go and pick up those soil samples and return them to Earth for extensive surveys and studies. On the right-hand side of your screen, you see Ingenuity. And that's a helicopter that's going along with the rover to Mars. Upon landing, the Ingenuity helicopter will separate from Perseverance and will hopefully fly around the Martian surface. It's not going to be flying very long distances. However, this is the first time that NASA has ever, or any organization, has attempted to fly an helicopter on another body other than planet Earth. So it's going to be pretty exciting to see if they can get that to work. This program is being run out of JPL in Pasadena, California. All right, I'm not seeing anything else, no questions in the chat box. So let's move on and talk about NASA's Commercial Crew Program. As I mentioned earlier, the Space Shuttle program ended in 2011, and there was a major issue, and the issue was, how do we get American astronauts back and forth from the Earth to the International Space Station? And so since 2011, NASA has been paying the Russian government to transfer American astronauts back and forth to the International Space Station. But NASA invited companies to take on that responsibility, private American companies. And so 2 companies were awarded contracts, SpaceX, founded by Elon Musk, and the Boeing company. And so it took a long time to get everything up and running, but things are finally working. And so on the left-hand side of your screen, you see the SpaceX facility at the Kennedy Space Center. This is Launch Complex 39A, where the Apollo mission rockets were launched from and some of the space shuttles were launched from. This is a Falcon 9 rocket that's used to ferry American astronauts back and forth to the International Space Station. And this is the SpaceX built their crew module, and they call it the Dragon Crew. And so this is where the astronauts go in this, and they go at the very top of the Falcon 9 rocket. And so I'm going to talk more about SpaceX in just one moment. I do want to mention Boeing. They also got a contract. They use the United Launch Alliance rockets, an Atlas, I believe they're using an Atlas 4 or Atlas 5 rocket to launch their astronaut capsule, which they've called the Starliner. Unfortunately, they've had some issues, some technical and software issues with the Starliner. They launched back from Cape Canaveral in December of 2019. They launched the Starliner. The goal, the mission was to dock with the International Space Station. There were no astronauts on board. Unfortunately, they were unable to dock because of software problems. So Boeing is taking a long look at their software issues, and so they've decided that they're going to do another test flight, and I believe that test flight will come, is currently planned for early 2021 with no astronauts on board, and then if all goes well, then they will take astronauts probably a few months after early 2021. But back to SpaceX, back on May the 30th, originally scheduled for May 27th, SpaceX did something that no private company has ever done in the world, and that is to launch astronauts from the Kennedy Space Center to the International Space Station. And so on the screen here at the bottom, you see Bob Behnken on the left-hand side of your screen and Doug Hurley on the right-hand side of your screen. These are 2 NASA astronauts that flew aboard the Crew Dragon that I showed you a moment ago on top of the Falcon 9 rocket. And so they docked with the International Space Station the following day after they were launched on May the 31st. And so they are currently on the International Space Station. Hence, going back to what I was talking about earlier with the International Space Station, there are currently 5 astronauts. Doug and Bob, Chris is the other American, and then there are 2 Russian cosmonauts currently on the International Space Station. Now, Bob and Doug are scheduled to come back in that SpaceX Crew Dragon capsule. NASA has not set a date as of yet, but kind of be watching the news, and I suspect probably sometime, probably next month would be my guess, probably August or no later than September, they should be returning, and that's going to be a big event, and probably NASA will be providing the public a lot of information about that. All right, it's 12:48, so I'm going to keep us moving. So there's a launch alert. The next launch is scheduled for Sunday, July the 19th, so just a few days from now at 5 o'clock p.m. Eastern Time. It's going to be a SpaceX Falcon 9 rocket, and it's going to launch a communication satellite for the South Korean military. I mentioned this website earlier. I want to show it to you, spaceflightnow.com. If you go to their website and you go to launch schedule, you will see every rocket, any place in the world, when it's scheduled to be launched, aboard what type of a rocket, what it is that's being launched, what time. And so it's a great website to learn about all launches. So it's spaceflightnow.com. All right. Now, let's move on and talk about a couple things that are upcoming for NASA. And there are many things, but there are two that I'd like to talk about. One is the James Webb Space Telescope, and the other one is the Space Launch System and the Orion Capsule. Let's start with the James Webb Space Telescope. This is the successor to the famous Hubble Space Telescope. It's scheduled to be launched next year. It's been delayed many, many times for a number of reasons. Unlike the Hubble Space Telescope that operates only about 350 miles above the Earth, this will operate at roughly about 1 million miles from Earth. And one of the major reasons is it needs to be away from the heat that the Earth will naturally generate. This needs to be operating in very cold temperatures. The James Webb Space Telescope will use infrared photography. And why are they using that? Well, infrared photography will allow scientists to look into the clouds of dust and gas that often block our ability to see stars, for example, in our solar system. And so they want to get a good look at some of these stars, and if they use visible photography, they're unable to look through that cloud of dust and gas. So this is going to be a really exciting space telescope. They're hopefully going to get this right, because once you launch this thing and it goes out 1 million miles from Earth, if things don't work well and something breaks, something doesn't work right, something doesn't open, there's no way of fixing it. So let me show you a quick little video about the James Webb.
The James Webb Space Telescope is the next premier space observatory. It will extend the discoveries of the Hubble Space Telescope and observe the birthplaces of planets, stars, and galaxies. It is named after James Webb, NASA's second administrator and champion of many NASA science missions. At 3 stories high and the size of a tennis court, this will be the largest telescope ever sent into space, and 100 times more powerful than Hubble. It is so big it has to fold to fit into the rocket only 5.5 meters wide, and unfolds segment by segment once in space. Webb's mirrors are coated with a super thin layer of gold that is about 1,000 atoms thick to optimize their reflectivity in the infrared. Webb will launch from French Guiana. It is launched near the equator, taking advantage of Earth's greater rotation speed there to boost launch performance. Webb will orbit the Sun 1 million miles from Earth at the second Sun-Earth Lagrange point. The telescope will observe infrared light with unprecedented sensitivity. It will see the first galaxies born after the Big Bang over 13.5 billion years ago. Webb's infrared cameras are so sensitive, they must block light from the Sun, Earth, and Moon. The 5-layer sun shield is like having sunblock of SPF 1 million. international mission. With contributions from the European Space Agency and Canadian Space Agency. Scientists all over the world will be able to use Webb to explore further into space and back into time.
All right. So pretty exciting. Okay, and I want to talk about one other thing when it comes to the future of NASA, and that's what's called the Space Launch System, or SLS. So the major goal now of NASA is to return back to the moon and plan for our mission onto Mars. And how will we do that? On the left-hand side of your screen, you see the rocket that will be used to return us to the moon, and this is called the Space Launch System. The official Artemis program logo is on the right-hand side of your screen. And if you are familiar with Greek mythology, Artemis is the twin sister of Apollo. The SLS rocket is a heavy lift, deep space hardware rocket. What does that mean? It's really, really big and extremely powerful. It's evolvable. What does that mean? That means that it can be used, here on the right-hand side of your screen, in different configurations. It can be used to carry astronauts, as it is on the two on the left, or it could be used to ferry cargo, as the two you see on the right-hand side. Artemis 1 is currently scheduled for fall of 2021. That mission will take astronauts, will not take astronauts. That mission will simply do a full test of the SLS and the Orion capsule, will go to the moon, and will return back to Earth with no astronauts on board. Artemis 2, which will have astronauts on board, currently 4 astronauts scheduled to go. This is scheduled for sometime between late 2022 and early 2023. It will have 4 astronauts on board. They will go around to the moon and come back, doing again a full test of all of these systems, the hardware and the software for the Space Launch System and the Orion space capsule. If all goes well, then Artemis 3 is scheduled for 2024, and that is our return to the moon, where human astronauts or American astronauts will land on the moon. And this same rocket system will be used for us to go to Mars sometime in the 2030s. The Orion capsule, this is what the astronauts will travel in. It will return to Earth at about 24,500 miles per hour. That's significantly faster than what the space shuttle returned to Earth from. And the reason is because, keep in mind, again, the space shuttle was only about 250 miles above the Earth, whereas the Orion crew capsule will go to the moon and onto Mars one day, so it's coming from a much further distance. It can accommodate up to 5 astronauts, however, it will probably only have 4. That's the information that NASA has provided to us. Let's take this short video.
Trouble hearing? Don't skip this video. If you're suffering from premature hearing loss, the struggle could soon be over.
Here.
Thanks to recent technological advances.
Here's a very short video.
Between 1968 and 1972,
SLS
America launched
Orion.
9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach: pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit, and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
Okay, I hope you enjoyed that video. All right, I'm going to skip this video that I have. Just recently, NASA announced contracts for several companies when it comes to creating some of the hardware that was talked about in the video that I just showed you. I mentioned earlier Artemis 1, referred to also as Exploration Mission 1. This slide has a whole bunch of information on it, but basically shows you what the plan is for the first mission of the Artemis program. This is Artemis 2. Keep in mind this is the one that will have 4 astronauts on board sometime in late 2022, early 2023. A lot of stuff going on here. Again, this is the plan as of now. And as we're starting to wrap it up, because I do see that we are just over the top of the hour, I do want to mention, though I am encouraged not to, I think it's important that people understand what kind of budget NASA gets. NASA gets blank percent of the total U.S. federal budget. A lot of people think that NASA gets a lot of the overall budget. And it's actually it's less than 1%. NASA only actually gets a half of 1 penny, a half of 1% of the entire federal budget. But I think all the things that they do with that money is well worth what they're doing. All right, I mentioned at the very beginning of this program, there are lots of ways that you can get involved beyond this presentation today with websites and doing things that you can learn more about NASA's missions and programs. One would be going to nasa.gov. Just an incredible amount of information that's there. You can do NASA Science, Citizen Science by typing in Citizen Science in Google, and it will tell you how you can, as a citizen, do science. If you are wanting to keep track of things that are headed towards the Earth, you can go to the Center for Near-Earth Object Studies, CNEOS, and follow those objects that are coming toward us. You can do some observing with NASA. You can, for example, take pictures of deep sky objects without a personal telescope or even a camera. You don't even have to leave your couch. You can go onto a website, ask a telescope to take a picture for you. It will take a picture and email it to you. So check out Observing with NASA. And probably the most exciting one to me up here that I really, really love a lot and I can't speak enough about is NASA Eyes. I highly recommend that when you get done with this program that you take a minute and go into Google, type in NASA Eyes, and you have to download a small little program. It doesn't take up a lot of space on your computer, but it is truly one of the most incredible software programs I have ever seen. And allows you to have eyes on the Earth, eyes on our solar system, or eyes on exoplanets. And for those that might not be familiar, an exoplanet is a planet outside of our solar system. So I can't speak enough about how awesome NASA Eyes is. So check that out. Google NASA Eyes. Before I leave you, I do want to mention again that I have 3 upcoming programs, YouTube live programs. These are very different than the ones I've been doing. These are very specific to, is there life out there? All about stars and all about the planets. Tuesday, July 28th is the first one coming up, 7:30 p.m. Eastern Time. Monday, August 24th, 7:30, about stars, and Wednesday, September 30th, 7:30, the planet. So I hope that you can join me. I hope that you'd like to join me, and I hope that you can join me. Simply come back to my YouTube channel 5 minutes before those start times. Look for the YouTube live event to occur and click on it and join me. I think it will be pretty exciting. Don't forget to subscribe to my YouTube channel. Turn on notifications. That way you know when I'm posting new content. I do quick little advertisements about upcoming YouTube live events, and so you are, if you have your notifications turned on, you know when those live events are coming up, and you can tune in if you so want to. All right, Q&A. Does anyone have any questions? Anyone have any questions for me? Looking in the chat box, I'm not seeing anything. So I really highly appreciate you coming and spending some of your time with me today. And I do hope to see you back on July the 28th at 7:30 p.m. Eastern Time. So for those in Alabama, that will be 6:30 p.m. your time. All right. Again, thank you so much for joining me. What's your favorite mini topic in astronomy? I see. My favorite topic is probably about life. Is there life beyond Earth? That gets me very excited about the potential that we are not the only things in town, per se. And so a lot of cool things I'm going to be talking about on July 28th regarding life in the universe. All right, well, you're welcome. You're welcome, Taga, Prattsville Public Library. You are welcome. I was so glad to be able to do this for you, and I hope to see you all back on July 28th. So thanks for joining me, and have a great rest of your day. Bye-bye.
The James Webb Space Telescope is the next premier space observatory. It will extend the discoveries of the Hubble Space Telescope and observe the birthplaces of planets, stars, and galaxies. It is named after James Webb, NASA's second administrator and champion of many NASA science missions. At 3 stories high and the size of a tennis court, this will be the